Hello, hackers. Give me 1 second and you'll be able to see me. There we go. Oh, amazing. Hello, hackers, and welcome. I'm Quinn. I'm a coach at Major League Hacking. I hope you're all having a great Global Hack Week so far. Today, we're going to be building our first, or maybe you built one before, but for some of you, maybe this will be your first LLM AI agent. And we'll be doing it using something called LangChain, which is a technology that is open source and free for us to use, which is super nice. It's also pretty industry standard, used all over the place, and built so that you can deploy things into production with it. So it's great for scalable apps and whatever else you want to do with it. Excellent. What I would love for you all to do, if you can, is to check in. I'm just going to pop the link up on the screen. Hopefully you can see it here, this way, and it's also in the chat. That's on YouTube and Twitch as well. I'm glad to hear that it's been a lot of learning this week. Pretty intense. Yeah, Global Hack Week can be intense. Definitely don't try and attempt everything, would be my suggestion. Otherwise it can get pretty overwhelming. But I'm glad you're looking forward to this stream. Hopefully we're all going to learn a lot. Also, I'm going to give it maybe one more minute, just in case there's some folks trying to get through the Twitch ads, and then we will get started. We'll put some music on as well. Hear me. I have, as a little heads up to everyone, I have a second screen. It's down in front of me. I'm just going to move things around a little bit. It's down in front of me, which means if I'm looking down here, I am in fact looking at your comments and things. So don't worry, I'm not ignoring you. In fact, when I'm looking away, it's probably more likely that I'm reading the chat messages and things. Awesome. Okay. Hello, welcome. Okay, great. So I think we'll get started very soon. And I'm just going to share my screen for us to get started. Perfect. Okay. Hopefully you can all see this. Let me know if you can see my screen. Should be all sharing correctly. Hello, welcome. I see we've got some more people joining. We're going to be talking through building our first open source AI agent using LangChain. This is going to be pretty beginner friendly, and we're going to talk through right from scratch. Okay, I think we'll get started. So the first thing that I want to discuss is like what stuff is out there. And as a little bit of context, I recently did a really great course called Arena, and I've taken some content from this. You can find some of the material that I used in their curriculum. They teach all sorts of interesting things if you're interested in working with LLMs, but in particular, when you evaluate LLMs, it's pretty common to use this tool called Inspect AI, which is developed by a regulator in the UK, and it's used for AI safety and how we evaluate models. And in particular, there's some stuff in this section here on LLM agents, and you can build agents using this tool called Inspect. Now, we're not going to be using Inspect today, but I thought it was maybe a useful bit of insight and maybe a useful link if you're interested. I might actually just pop that in the chat if anyone's interested in checking it out. I think it's really great, and there we go. There you go, in the chat. I think this is really great. You can build agents with this and evaluate them as well. And it's got its own kind of setup. We're going to be using LangChain, which is a bit different, but this is also an open source tool which you can use, I think. Yeah, there you go. You can check out their GitHub as well. It's got all the details that you could ever want. This is, in my opinion, a really great tool as well. But we're not going to be using that today, although I might reference it now and then. What we will be using is LangChain. Maybe you've heard of LangChain before. It is just a platform, a technology, a tool that we can use to build AI agents. And let's see if we've got like an intro page here somewhere. Oh, this is not really what I'm looking for. I want like python.langchain introduction. Here we go. And helpfully, as you can see at the top, it points out quite accurately that these docs are going to be updated at some point with the release of version 1 for LangChain. So at the moment we're on version 0.3, and you can check out the newer docs here. We're not going to use these because as you can see, it's under active development and like might be a bit funky, and the latest stable version is version 0, so, or at least the most kind of useful and accurate docs. So this is kind of like going to be our point of reference. LangChain is something that's also fairly new to me. I haven't developed with it a ton, so we're going to be learning together. Otherwise, I've said I've built LLM agents a few times in the past, so I think we'll be able to work this out. Awesome. Okay, so a little bit of introduction to LangChain. It's just a framework that we use to build agentic AI, and it's got some extensions. These include things like LangGraph. LangGraph, it allows us to build perhaps more robust applications and also multi-actor applications, so when we have multiple agents at once. And we model using edges and nodes, just like in a graph. If you've done an introductory computer science course, this is maybe a familiar thing to you. There's also Langsmith. We might get on to use this as well. And yeah, Langsmith allows us to do more of the kind of production side of things, so debugging, testing, evaluating, monitoring as well. So super great and useful tools. I think first though, let's talk a little bit about what an agent is. Maybe this is something which is kind of new to us. Oh, and as a little heads up, in case it's not completely obvious, LangChain is open source. You can check out their GitHub. I'll type that out in the chat as well. Actually, maybe that's a useful link. There we go. Oh, I've got a typo in that link. I'm sorry, I can't edit it after the fact. It should be a period, a full stop instead of a comma. GitHub.com, GitHub comma. Can I share the Arena website link too? Yeah, sure. That's just arena.education. What other questions do we have? Are we going to be using one of their LangChain Academy projects? No, we're not, but I do think they are really good. I haven't built any through their kind of tutorials or anything myself, but they seem pretty great. We're going to be building things a little bit more from scratch ourselves, just so we kind of teach the intuition. We're going to be learning a little bit more conceptually about what agents are and how to build them. So we're maybe going to be a little bit lower level than some of their tutorials are, and a bit more in detail. We'll see how we get on. Okay. Awesome. So let's talk about what LLMs, chains, and agents are. We'll get to setting up a virtual environment in a minute. I'm going to use VS Code, by the way, but like, you can use whatever you like, as long as you're comfortable with it. And I guess in terms of prerequisites for this workshop, I'm thinking basically just Python. That's pretty much it. Oh, and as a heads up, this is a two-parter, so we'll see how far we get on today. The next part is tomorrow. I think it's in like 26 hours or something. Yeah, so we'll see how far we get, and then we can maybe tomorrow we'll have like a little bit of an easier session if we've made good progress, or maybe tomorrow we'll have to do some catch up. We will see. Okay, so we're going to be learning what an LLM is. What prompts are. Hopefully you kind of know what a prompt is. You probably interacted with ChatGPT or something like that in your browser. Maybe you've interacted with an LLM via API. Maybe you've seen the Gemini demo. I think Cecilia did it in Today in Global Hack Week on day 2. You can check that out if you're interested on the MLH YouTube. And then we're going to talk about what is a chain, why is it called LangChain, what is a chain, and what is an agent, what is the difference, and how does an agent use tools, what are tools, what is reasoning, what is acting, what are these things, and we're going to be using Gemini in particular because we get easier access to Gemini, but we could use other models as well. We could use open source models, if you're interested, they might struggle a little bit more with tool usage, so you have to be careful which one you pick. And you might also need a reasonable amount of compute. You might be able to do this on Colab if you get lucky with getting a big GPU. I think you might be able to do it on a T4, which you can get for free. But it's going to depend on your model. What I would suggest is maybe trying Llama 8B if you want to use an open source model. And you can find that by going on Hugging Face would be my recommendation. Let's see. Yeah, Llama 3 8B is maybe one of the better models to try. Although again, I'm not 100% sure it's going to manage well with the tool usage. So that's something to be aware of. Also, I believe this is a gated model. Yeah, it is a gated model. I think I already have access to this, but you will have to scroll through and accept all of these details and fill out this and then click submit. Okay. But yeah, we're going to be using Gemini primarily. It's just if you wanted an alternative option and if you wanted to stick truly to the kind of open source specification. Perfect. Okay, right. So let's talk a little bit more about what an LLM is. So at its core, an LLM is just a system that's trained to predict the next token. And a token is just a piece of a text or a piece of a string, maybe is better way to say it. It doesn't have to be a word, might be part of a word, might be a number, might be a symbol, could be many different things. But typically these are parts of words or whole words if the words are short. These are chunks that basically come together often in the training data that we feed into this model, this large language model. And when we feed in our prompt, a large language model just continues from your prompt predicting the next word. And if we don't fine-tune it, do this thing called instruction fine-tuning, it will just keep continuing. It won't be able to answer any questions. So for example, if we said, where are the beans? An LLM that hasn't been fine-tuned to understand that might go, where are the beans? And then it continues, said Jack to the giant. And it might continue it as if it's retelling Jack and the Beanstalk, right? Often this is the case with large language models that haven't been fine-tuned. They kind of just continue things as if they're stories or pieces of text, depending on what their training data is primarily made up of. Okay, and the way that it picks the next token is it maximizes some probability over some distribution, which is just a way of saying it's got some curve which says how likely each token is to be the next token. Okay, so if we said Jack and the bean, it might think, oh, the next token's stork. Okay, that would be a likely prediction. Okay, whereas it would be unlikely for it to predict, I don't know, mechanical keyboard, right? Has the next few tokens. That would be many tokens, really. But yeah, okay. Hopefully that makes sense. All right. So another example, if we said the capital of France is, it would say Paris, hopefully, if it's been trained on accurate data. And more complex tasks, like I said, answering a question or summarizing some text or planning. These things are fine-tuned in, and this is a good kind of very quick fundamental idea of what an LLM is and how it works. And when we talk to a model, we typically define our inputs into layers, and we have a system layer. Often this involves a system prompt. You've probably heard of this, and this tells the model its role, maybe its constraints, maybe there's things that we want it to do or not do, and also maybe its style, if we want it to be friendly, or if we want it to be blunt and to the point, or if we want it to be poetic, or if we want it to speak like a pirate. Okay, and then we also have a user level. This might involve a user prompt or message, some task which has been assigned. What do we want it to do, right? So, for example, this could be, solve this quadratic equation, okay? And we could also give it some examples. We call this few-shot prompting. This is where maybe we will give it 3 quadratic equations, and we've given it the solutions to 3 of them, and then we give it another equation and we say, now solve this one. And this is, in this way, we kind of show the model what we want it to do. This is few-shot prompting. Perfect. Okay. All right, and all of these different prompting methods just shape the model's next token predictions. They change the probabilities in the next tokens. Okay, great. Now, when we're building an agent, it has these things called tools. And when you do a task, right, let's say I asked you, okay, what is the capital of France and what is its population? You probably don't know the population of France off the top of your head. But if I said, can you go and find that out for me? You probably could, right? You could Google it. You could maybe get a textbook or, I don't know, an encyclopedia, right? There are a bunch of different tools that you have available to you to find out this information. And so when we build an agent, we wanted to recognize, this is something which I don't know and I need to find out. And I will go and do that. And so it could use Google, or it could use a calculator, right, if we wanted it to solve some equation. Okay? And so when we are prompting our model, we have those components, the system, user, and perhaps few-shot levels. But we also have what we tell it within those. And the key things really are what tools it has available, how it should produce output. Okay, so do we have any required formats, any specific syntax that it should follow? Should it provide citations? These kind of things. This is erring on the stylistic side, but if, for example, we ask a model to use a tool and then it has to fill in, some parameters in a function, it has to do this correctly according to the syntax of the tool. Okay, and so we need to make sure that we specify that. And then we should maybe also tell it what it shouldn't do. So anything unsafe, it shouldn't, if we give it access to a terminal, it shouldn't install a virus, right? Or delete your database, these kind of things, okay? So the prompt becomes an interface between our code and also the model's reasoning, yeah? And a well-constructed prompt allows us to steer the model more reliably. I hope that's making sense. Let me check. Let's see if we've got any questions. We might get onto LangGraph. We'll see how we go. Can we get the doc that you're going through? I might share it at the end. We'll see. Is it possible for me to increase streaming quality? I don't think so. It should be very high quality already. I suspect if you have any issues with the resolution, it's probably internet on your end. Hard to read text on the current resolution. Can't make anything out on the screen. I mean, I can make it bigger. It's 720p. Let me see what I can do about this. I might be able to change the quality. I can't change the quality. We're stuck in 720p. It should be high definition though. At least on my end, it's saying that it's high definition. This should be sufficient. We don't typically have issues with the resolution. What I can do for you is I can make this bigger. That's kind of huge on my screen. We can go for this. This is fine. So now that we kind of had a little bit of an overview of what an LLM is and like maybe how we would want to prompt an agent, but we maybe still don't know what an agent is. Let's before we get too into things, make a project directory. Okay. And I'm going to do that by creating opening a new folder. You could do that by clicking here, or you can do Control K, Control O. Okay, so I'll open up a window like this. This is just bits and pieces in my user directory. And then I'm going to go into my documents, and I'm going to head down here to projects, and I'm going to make a new folder. You can do this in the command line if you prefer. I'm going to call it LangChain agents. And let's open this up. I'm going to select that folder. And VS Code is going to do all sorts of bits and pieces for us. We've got Copilot here on the side. We're not going to use that for now. But you notice this has actually got an agentic mode. As an example of what an agent is, we can use Copilot and it will interact with our IDE. It can use tools like the terminal. It can create files. It can do all sorts of things. It can use web search. And then it can write code for us. Okay. This is different to if we had it in ask mode, where it would just respond to our questions. Actually, ask mode is technically also an agent because it can read the code and go through our project directory as well and reference things, but for now, let's just kind of imagine that this is just a chat interface. Okay, perfect. All right, but we're going to close that for now. We don't need it. We don't need it right now. And let's make a new file, and I'm going to make a Jupyter notebook. And this is going to be all sorts of unhappy because I haven't made an environment or done anything like that. So maybe we'll do that first. Making it bigger would help. Yeah, hopefully this is big enough. This is kind of massive on my screen. But I can make it a little bigger. I just think this is like we are losing real estate on the screen very quickly. So hopefully this is fine. But let me know if it's still not very readable, and I can see what I can do. Okay, perfect. Right. How to make on a Mac? I don't know the shortcuts on a Mac, but if you go up here and you click open folder, this is the button that you want, and you should have this. So file, open folder, and then you can just make a new folder. It's okay? Okay, good. Perfect. All right. Right, what we need to do now is we need to go into our terminal and we need to make an environment. Okay, and you can, by the way, if you prefer, use Colab. As I mentioned, if you want to use an open source model, you might prefer that. I've done that a few times in my past streams. You can check them out if you're interested in open source LLMs. I can drop a link to that if anyone wants to go back and check those out. Okay, but in the meantime, let's go into our terminal, which isn't working for me right now. That's kind of weird. I'm gonna just, okay, that's better, right. Okay, and I'm going to make a virtual environment. And I'm gonna give it a name. I'm gonna call it agent env. And then let's call the folder where we're saving one of our packages .env. Okay. And we're going to let that do its thing for a bit. Perfect. Okay, now you can see we've got a virtual environment that's popped up here, and we need to activate it. It's currently not activated. You'd see the little name here if it was. So we can do source, and then on my device, this is the command to activate it. Now this will vary whether you're on a Mac or not, and also depending on what terminal you're using. I'm using Git Bash. If you're using PowerShell, it might be slightly different. This is what works for me. If you're having trouble activating your environment, let me know. I'll try and help. But often it will pop up down here with a little activate your environment button, and you can press that as well. But I'm going to type this out, and you can see now we've got this activated. So we can see I've got agent env, which is what I named it here, and that's corresponding to this folder here. You don't have to include this prompt, but I just like it having a different name here. It means if I've got like lots of stuff going on, I can remember which environment I'm in. Okay. And because the installs take a while, let's do them now, and then while we talk through some things, we can just let it run, okay? And I'm going to install like a whole bunch of things, I think, and then we'll see how many we end up using today. I'm not actually sure how far we'll get on. I'm just pulling up a little list of installs. Give me 1 second. Okay, perfect. So we're going to pip install, and let's pip install LangChain Google Gen AI. And let's also pip install LangChain Core Google Generative AI. We're going to pip install Sentence Transformers. Install this and this. We'll talk through all of these as we get to them. I don't want you to worry too much about them. Probably won't use PDF Plumber, but we'll see. And okay, perfect. Let's let that run. Okay. Most of this stuff is just LangChain, and as you can see, like all of this Gemini stuff. This is Google, of course. Radio allows us to create a nice UI pretty easily. It's a bit like Streamlit. I've used Streamlit quite a lot in previous streams as well. Perfect. Okay, in the meantime, yeah, if you haven't already, make one of these, and maybe we'll save this. Oh, that's not what I wanted. There we go. We'll save this here, and we'll just save it as like main. Perfect. And let's select a Python environment. We'll choose agent env. Great. And let's make a markdown cell. So I'm going to make some notes as we go. We've spoken a little bit about. Let's give this a title actually. An introduction to LangChain and agentic AI. Okay, and so we've spoken a little bit about what is an LLM, how does it work. We've covered this. Not gonna write all that down, but hopefully it makes sense. And we've spoken a little bit about prompts and controlling a model, i.e. this was system. This was like system prompt. What else do we have? We had a user prompt. We had strategies like few shots prompting. And then we also discussed some other bits and pieces like prompts with available tools, output schema perhaps, safety constraints, e.g. what oh, that's not what I want. What shouldn't our model do? Okay, perfect. And then okay, now let's talk a little bit about what are chains and what are agents. So what are chains and agents? So a chain is just like a fixed recipe, okay? This is some pre-designed sequence of steps, and we might decide ahead of time how this flow works. This is the typical way of doing it, and there is no branching or decision making by the model in a chain. Okay. For example, we might. Okay, let's have an example for RAG. Okay. And if you haven't heard of RAG before, this is just retrieval augmented generation. This is basically when we feed documents into our model, right? And we might first split a long document into chunks. This would maybe be the first step, and then the next step would be probably computing the embeddings. This is just how we represent our tokens, which are just, remember, chunks of words or chunks of strings. And then for a query, we compute the top k most relevant chunks from these embeddings. And then we feed the chunks, and the query to the LLM. Okay, and then finally, we produce some summary or answer. Okay, hopefully that all makes sense. If you're not familiar with the RAG, don't worry, but this is just an example of like something we might want to do with our model. We might have some documents that we want to use. We might have an encyclopedia, for example, wanted to look up the capital of France, whatever. We want it to be able to find that, and so this is a series of steps which we take to do that. This is a recipe, if you like. Okay, right, and in a chain we basically know in advance exactly which tools get used in what order. Okay, we're just telling the model what to do. Okay, an agent is a little different. Okay, this involves the kind of more runtime decision making. Okay, let me just check and see if we've got any questions. Okay, sorry. Yeah, I didn't drop all of the packages I installed in the chat. Let me pop those in. Good shout. They should be, actually, they are still up on the screen, to be fair. But I can type them out. So we need LangChain, Google Gen AI, LangChain Core, Google Generative AI, Sentence Transformers, by CPU, Pydantic. We want requests and radio. Probably don't need PDF Primer, but these are the ones that you want to install. You can just add in the notes. I'm not 100% sure what you're meaning here. Oh, put the installations in the notes. Yeah, I'm not going to share the notes like right now, but I could put them up here as well, but like they are on screen here, so it feels a bit obsolete. We don't really need that. We can make a requirements.txt as well. Maybe we should do that. We can do that in a bit, maybe. Okay. Perfect. Okay, so we know what a chain is. Let's talk a little bit about what an agent is. All right. Okay. So this is where we have runtime decision making. So this is more flexible, right? And what else to say? In this case, we have a model that decides. There we go. Look how long that took. That took forever. It's finally finished. A model that decides what tool to use, and when. Often and when, but not always. Maybe we'll just delete that. That's maybe confusing. But definitely decides what tool to use based on what it has learned so far. Okay, and it can. This is basically, right, an agent is basically just an LLM wrapped in a for loop, okay? And we basically just loop over this process. We ask the model to reason about what it should do. So maybe we say, okay, what is the capital of France? We ask the model to reason what it should do, bearing in mind the tools that it has. And it might go, I have access to Google, a search engine, and I don't know what the capital of France is. So I need to use the search engine to search capital of France. Okay, that is its reasoning step. And then it's got an acting step. This is where it might call a tool. Okay, call a tool, and then we have an observation step. Okay, the model will model sees. Do we have an apostrophe there? I don't think we do. Sees output from tool. And whatever that output may be, or not necessarily even an output, but sees observation from a tool. Okay, and then it reasons again. Okay, and then we loop. Okay, perfect. And we often call this in fact, yeah, we can get rid of that. Get some more space. We often call this the react loop. Okay, and this stands for reason, act, okay, or action. Perfect. Okay, so we have reason, given what we know, what is the next best action? And then we have act. This is call a tool, or could even be answer now, if the model just kind of knows or is happy, or maybe it's been through this loop a couple of times and it's got the solution that it needs. And then we also have observe, and we're going to read the tools. We can call it the output. Like it is basically an output from a function, so this is mostly true. But there are cases where it might not be like a literal output. So it might try and use a tool and use it incorrectly and then get just an error, right? And it will observe the error and then say, okay, based on that, I need to adjust how I'm using this tool. Okay. And then we repeat, or we could conclude, but we probably won't conclude at this point because we need to reason again and then act, which is where we do the conclusion. So we won't really conclude that. But you can think of it as concluding after this observation, if you like. Okay. Perfect. Hopefully this is making sense. I had some diagrams which I wanted to share, but they seem to have gone missing. So please bear with me as I find these. Wouldn't be a technical workshop without some technical difficulties, am I right? Let's see what I can do about this. In the meantime, let me know if you get any questions. Will we get the repo for this? Yeah, I can throw this onto my GitHub and share it with you all. No problem at all. I thought I had some. I do. Okay, we're good. Don't worry. Okay. So we've discussed a little bit all of this stuff, right? We've spoken about what a chain is, what an agent is, and what this React loop is, okay? And so this is maybe a helpful diagram. This is made with Mermaid. It's really nice. I'm using Obsidian for my notes. I recommend Obsidian. This is just Markdown. And we have an agent, and it makes some runtime decisions, okay? So we have a user's question, and then based on that question, i.e., what is the capital of France? We might reason or plan, then we might call a tool. This is called invoking a tool. In LangChain, at least, it's, we call it with our model.invoke. And then we have an observation, and then we reason or update, and then we might answer and return the answer, or we might loop back around, okay? A chain is fixed, right? We have a user's question, we might retrieve some relevant text, we might feed it to the model and the prompt, with the prompt even, and then we might get some answer out. And this is a nice analogy that I like. If you think that the chain is a recipe, then the agent is the chef, okay? It's in a kitchen, it can taste different bits and pieces, it can look in the pantry, in its cupboard, its shelves, find the ingredients, and try different things out, and turn the oven on and off, right? And it might have a recipe that it follows, so this would be our chain, and it might have this recipe step by step, okay? So it might use that recipe to perform its tasks. Okay, next let's talk a little bit about the tools that we have. These could be a bunch of different things. We've mentioned some already, right? A search engine is the obvious one, web search. We could have Wikipedia lookup, or encyclopedia if you're a bit old-fashioned, but Wikipedia probably makes more sense. A calculator is another common one because LLMs are not very good at maths, and often people want to ask mathematical questions. And then we can also retrieve content from a document. This is what we call ragging, or even just any other external API call, okay? And we have to declare a tool in a standard way. In particular, we need the name of this tool. This is normally a function. And, oh, that broke things, didn't it? There we go. We have some description. This is required so the model can know how to use it. So if you're used to writing functions and not putting in doc strings, bad, this will not work. To have a tool, you need to have a doc string, or can you do it without a doc string? You might be able to do it without a doc string, but I think it will be harder. It should throw an error if you don't give it a doc string, because it doesn't know how to use the function. And then we need some schema, okay, what parameters it should take. And we can force certain models to do this with tools that their providers supply, and then the kind of return type. So we might have a model that chooses to look up on the internet, what is the capital of France, right? I might just put in that question. Or, if we wanted it to ask, okay, tell us what Python is in coding, it might search Python programming language, okay? And Gemini, which we're going to be using, supports function calling. So the model can output a structured JSON. This is what I was just saying. The provider allows us to force some schema onto the model, which means that we can specify some function naming arguments. Okay, and if you want to, you can check out here all of the information on function calling. Okay, hopefully useful. Perfect. Oh, I've lost my tabs. Okay, perfect. All right, so tools are great because our models are bad at certain things, like knowing facts. They don't always know all of the facts, and doing maths, right? So tools are great, and this is basically what an agent is. It is a loop of reasoning and acting over and over and over. And it doesn't just have to be tools. We could make an agent that sends emails for us. So it's not just necessarily using tools to find out information, but it can also use tools literally to act. So we could have a personal assistant agent to interact with our calendar. This would be a little bit more complicated than what we're going to be doing in this workshop. Okay. All right. Let's talk about this next. So putting that all together, this is our process. All right. So our model will plan, produce some idea using its reasoning step, and then it will choose an action or answer. This is the reasoning step, these two here, and then it might pick to do a web search or retrieve some information using the docs, and then this would implement a chain where we retrieve and find the relevant docs which we return into the model, or we could use a web search where we call a tool. Okay, this will produce some search results, and then we can update our memory. We might give the model a scratch pad, which is just basically like a TXT, and then it can keep going with another tool and move back maybe into web search or maybe into something else, and it could also finish at this point and then produce a final answer. It might produce some citations or references, and then it can return that to the user, and then we can go around again and again in a chat interface. Okay, and this is what an agent is. This is from arena.education. I really like this, and I think it's a helpful little diagram, but it demonstrates that basically what we have with our model is just a loop, right? We have a loop with an API call to an LLM, and in that loop it can reason. We build this scaffolding program. We can do this in LangChain, which provides most of the framework for us. We could do this from scratch. It would take forever. Well, it wouldn't take forever. It would just be a little bit tricky. And in the scaffolding program, we provide prompts. We, allow the model to execute tools. We ensure that we maintain the history of all of the communication that's happened. And from this scaffold, the model can reason about what actions it wants to take and then take the actions. This interacts with the external world, including APIs, terminals, web browsing, virtual machines, anything you like. Get some results out, and this loops. Okay. In particular, we keep some idea of what it knows so far. This is the history. We record this in some state, memory, scratchpad, whatever you like, and we iterate. Okay. I also like this. These are the kind of core functionalities of an LLM agent. We have obviously the API, the interface. We have the tools, which we've discussed. We have the task or state management. This is handled through LangChain. We have the memory as well. We'll probably get onto that tomorrow. We have an observation parser, which allows us to prepare the input and pass the output of the LLM. And then we have the execution logic. This is maybe more like a chain, right? This is a recipe for how one loop of the agent is executed. And then we have the task-specific information. Oh, excuse me, a bit sleepy today. This might include instructions or files, okay? Is this tool still too small? We can make this bigger. I can't drop this in chat because it's not a slide and I can't share files very easily, so maybe I'll put this on my GitHub after the workshop. We'll see about that. Okay, so there's a bunch of different things that we can do before we actually get into the coding, which we're going to do very soon, don't worry. But we could use a local model. As I've discussed this, we would want to quantize it. We do this in a bunch of different ways. Bits and bytes is a library that's often used, spelled bits and then BYTES, bytes. I recommend that if you're on Linux. It doesn't work on Windows or Mac OS, I believe, but you can use it on Colab. And then there are like some other formats that we can use, but we're not going to get into this because this will take like maybe 30 minutes to load a model, and it's generally just going to cause us problems. Okay. All right, so let's get into the coding. So we've got an overview here. This is kind of really big. but this is fine. We've got an overview here of what a chain is, what an agent is, what an LLM is. And we've gone into more detail than I've put in the notes here, but this is good enough for now. All right. So, let me know if you have any questions at this point. This is probably a good point to pause and say that. There are some questions that might be obvious to ask at this point. For example, what if our agent uses a function incorrectly? This is going to happen at points. This is why we kind of add fallback logic, we add, error handling, guardrails, and all sorts of different bits and pieces. We'll do most of that tomorrow. Today we just want to get an agent working. That's kind of the goal for me. So it's not going to be perfect, but with all of the infrastructure around it, we can make it more secure. And in many ways, unlike some of the other kind of AI development, building an AI agent is more of an engineering task than it is, a research task, which, AI development might be conventionally if you're using something like PyTorch, it can be more practical, but still a little bit more theoretical. Okay, so perfect. Another question that you might have is like, well, I might have a model, Phi 2 or Llama 3, 8B. There's a bunch of models out there, which if I ask, what is the capital of France? It knows it's Paris. Why do we need it to search these things? Why do they need a tool if it already knows all of this stuff? Well, the important thing is that when we train a model, its knowledge is static, right? It's not gonna, at the moment at least, models don't know how to learn. They can't update their weights, they can't learn more information and store it internally in their neural network architecture, okay? And so it needs some way to kind of check for up-to-date information, maybe even do computations, because remember, an LLM doesn't have, access to a piece of paper by default, which it can do maths on and write things down. Like, if we asked you to do a complicated maths problem, you'd probably need some tools too, okay? And it's much the same. Yes, we could say, oh, well, let's just build a model that knows everything from the start, but this is not feasible to do. And if new information is found or discovered, it won't know it and it won't have any way to reference it, okay? Unless we just put it in the prompt directly, and that's very manual and painful for us. So building agentically means that we don't have to do that, okay? Great. All right. Perfect. In the beginning, we're gonna build a very simple agent. This scratch paddle memory idea is gonna be really simple. It's just gonna be basically a buffer, a glorified string. But over time, we might build something that is a little bit more persistent between sessions, okay? All right, so the first thing is we're going to be using Gemini, and we generally get a bunch of free stuff with Gemini. Gemini is nice like that. Let's go and take a look at Gemini. If you're new to Gemini, zoom all the way down here. You can check out all of the different models available. On the free tier, you can use the Pro model, I believe. But if we check out the rate limits, it will be extremely low on newest models. Yes, we get 5 requests per minute on 2.5 Pro, which is not a ton. This is 125,000 tokens per minute, which is also not a ton. And that's 100 requests per day. Okay. Again, not a ton. The one that has the most at the moment is Gemini 2.0 Flash Lite, as far as I know. Probably there's like Gemma has a similar number. Yeah, Gemma has a similar number. It's got more requests per day, but fewer tokens per minute. So trade off there. I think this is like a good balance. There's also some of these models, but we don't want to use them anymore. Okay, so we're going to be using Gemini 2.0 Flash Lite. And yeah, we don't have to set up any billing information or anything. This is good for us. One thing to bear in mind is that we're probably going to hit some rate limits, and so we're going to have to do some clever throttling to make sure that we don't spam out the API, because otherwise we might get many rate limit errors, and that will cause us problems. Okay, we also want to minimize redundant API calls because that will increase our requests per minute. And again, we only have 30 of those, which is one every other second, right? That's 1 in 2 seconds, so that's not bad. But we can very quickly rack up API calls, and if you're doing this on a paid API, you really don't want to be doing that. But even here, we're going to hit rate limits, and that's going to be great. So let's not do that. So the first thing that we need to do is we need to get an API key. So if we go to Google AI Studio and we grab an API key here, you can log in. This is my hackathon email address. This is not what I want. Perfect. Okay, and you can see I've already got an API key here. I've called it GHW Workshops, Global Hack Week Workshops. You can see that I made this in advance yesterday. Oh yeah. You can make your own API key here. You can click Create API Key. You can name it whatever you like. You can make a project. You can create a new project here and give it a name. And then you can copy this here. I'm not going to do this on stream because that would be, well, actually I can copy it on stream, but I'm not going to show you it on stream because obviously I don't want to share my API key, and you also shouldn't. Make sure you don't commit this anywhere. You should keep it in an env or set in your environment in some way. Okay, and I'm going to give you all a minute to do that. I'm going to check for any questions. What do we have? Okay, first question, difference between RAG versus agent versus MCP. So while you all are getting your API key set up, let me talk through this. Yeah, oh, good suggestion. We can use python.env. This is good as well. Many different options here. Okay. So what is the difference between RAG and an agent and MCP? Well, RAG is like a tool, right? You can think of this as like the RAG process is like a chain, which our agent can use, like a recipe. So it's kind of a tool. MCP as well is also a tool, right? I believe this is open source as well. This is actually, I guess, technically not a tool. It's a standard for how we interact with external services, as it says here, actually. This is like how we interact with tools, or how we interact with data, how we connect to other sites, or maybe we've got examples here. Okay, integrating with tools like GitHub, connecting to a wide range of developer documentation, things like this. Okay, these are not what we're talking about. Okay, if you want to learn more about MCP, let's see, Major League Hacking Global Hack Week. You can do so. We had some streams this week on it, I believe. Let me find them for you, because I think they were run by Way, and they would have been super good. Yeah, okay, we had the first one on day 1, and the second one was day 2, so that would have been Saturday. At least it was Saturday for me. Yeah, there we go. All right, perfect. So if you want to learn how to kind of get yourself set up with an MCP server, communicating with clients and whatnot, this is a really great workshop for that. You can check that out on YouTube. Yeah. Okay, hopefully you've all got an API key now. Perfect. Mine is copied, and so we're going to type export and then like Gemini API key, and then we're going to paste it in here. But I'm not going to do this on stream. Got a question from Lily. I'm glad that you're enjoying how we explain this. I like to take things a little bit slower to make sure that we kind of get all the concepts. I think that's important. today we're going to build a simple chatbot that can use tools to help answer our questions. But you could do this to build a research assistant. Yes, this is a really great suggestion. And yeah, you could do this to build some kind of automation tool with multiple steps involved as well. I think like a neat idea would be something that manages your like emails and calendar. These things almost certainly exist, but building this yourself, I think, would be really interesting because you're interacting with a bunch of different APIs, and this is going to be like non-trivial because the functions, the tools required to interact with those are going to be a little bit more complicated. So this is a good like follow-up from this kind of workshop series that I would suggest doing, but it's probably out of scope for at least the amount of time that we have. Okay, perfect. So I'm going to remove my screen, there we go, from being shared, and I'm going to set my API key, and then I'm going to create a new terminal, and I'm going to reactivate. Put that back up now. Yep. I'm going to reactivate my environment. Oh. There we go. Okay. Perfect. Okay, I did that and then closed the terminal because I didn't want you all to read my API key, but you could also put it in an env like this, or whatever you like. The choice is yours. Okay. Right. I'm going to give us a little pause while we have any potential questions. And I'm going to rejig my slides around and things. Let's see. Normally I have a second screen up. I have two screens right now, but one of them is my laptop. Normally I have a second screen up over here, and it's much bigger, and I have like much more space to play with. But alas, I cannot do that right now because the screen is broken for some reason, which is very sad for me. But it's okay. We'll get by. All right. Okay. Hopefully we are all kind of reaching a helpful point, and we've got to somewhere where we've got an API key in. So I actually don't have a Mac and don't know how to use a Mac, I'll be honest. Do you mean activating the virtual environment, or do you mean setting an environment variable for your API key? I think you should just be able to do the same thing. I can Google this for you if you want. Let's see what Google says. Google's not being very helpful right now. Oh, you mean the source commands? I can just look this up for you. I don't know off the top of my head, but I can look this up for you. So it's source VMV bin activate. So it is like like this. There you go. Yeah, hopefully not. Hopefully we're all using our own API keys and not someone else's. Otherwise, that would be sad. Okay, right. Let's get going because I think we're about an hour in, and so we've done lots of the theory. Let's do some actual programming. Okay. Perfect. Now, I'm thinking that we can use OpenAI. OpenAI Python SDK allows us to set the model endpoint to Google Gemini, I think. Yeah, I think we can use an API style client for Gemini. An OpenAI, sorry, style client. Yeah, let's have a little think about this. Okay, I think what we want to do, yeah, let's use the OpenAI star wrapper. We have like a bunch of different options here, okay? So we can use the OpenAI Python SDK. We could use like raw HTTP requests, JSON payloads. We could use the Google or like Vertex AI library. I think the easiest one is going to be using the OpenAI SDK. So let's try and do that. And if we have issues, we can swap. But the benefit of doing that is that we can pivot to using a different model if we wanted to at another point, and we'd just basically change where we're pointing to. Okay, you can see we've got some more questions. There we go. I used Python 3. Yeah, this is perfect. Activate it by running source bin activate. Great. Yeah, sorry, I think this is going to depend on what you call your version parameter. You could call it .bmv, which is what I did, but you could also call it just bmv. Excellent. OpenAI models have a fee. Yes, so we're not using an OpenAI model, we're using Gemini, but we're using OpenAI's SDK, which allows us to kind of standardize things. Hopefully, this is kind of, fingers crossed, gonna work. Yes, in the spirit of Open Source Week, we can also use the Swiss AI initiative. You know what? I've actually not come across this. Should we look it up? Yeah, like I said earlier, there are a bunch of different models that you can use. Swiss AI Hugging Face. Yeah, I'm not familiar with this. Looks pretty neat. Language model built for public good. Very interesting. Yeah, I mean, my concern would be that it would struggle with the kind of more agentic stuff. Like calling tools can require it to use a specific schema, right, when you're doing function calling in particular, so that might be an issue. But like, yeah, you're welcome to try this. When I was like prepping for this workshop, I found it a little hard using open source models directly with LangChain, but it's like definitely doable. I think it's just whether you've got enough compute. And I wanted to make sure that we could do this quickly and for free, because we don't want to sit around for another 30 minutes waiting for our model to download. Okay. Perfect. Right, OpenRouter. You can use OpenRouter. This is just another way to access a model through an API. You can also use, you can use open source models through OpenRouter, potentially for free. So this is maybe a better way of doing it than using Colab or like Compute. This might work. I'm not sure what the kind of most capable free model on OpenRouter is that's open source. So, but yeah, the way that we're going to build this, hopefully you can just sub in any model that you like. Okay. So we import OS. This is useful, and from OpenAPI, import OpenAPI, and we haven't actually installed this, so that's great for me. I think it's just OpenAI, right? Yeah. Okay. Perfect. And let's load our API key. You could use I don't know if this is gonna work. I think this will work. You could use .env, but this also works. Okay, and then we're gonna say maybe we'll put this in here. If not, API key. We will raise a runtime error. Perfect. Thank you, Copilot. Okay, and maybe we'll just run this. We need the IPy package, which I forgot to install as well. That's something we can do. Yeah, let's see it's installing now. Okay. It's taking a little minute, but that's okay. We'll keep working. So let's make a helper method, which we can call it Gemini Chats, and we'll put in some messages, and maybe we'll have some arguments in here as well. And this is going to be this is going to be a list of dictionaries. And we want with role. This could be like e.g. system, user, etc. and content. Okay, and then we're going to return our model response, which is going to be text plus metadata. Okay. Okay, and like we're just going to get our response out. This is just going to be like really simple, just to check that this works. And this might not work because using Gemini through the OpenAI SDK is a bit funky. We haven't defined a client yet either. We need to do that. Let's do that. Did this run? Okay, it ran halfway through. That's fine. Perfect. Yeah, that would help them. Okay. And then we're going to set the model to whatever we want to call it. Let's do Gemini 2.0 Flash Light. I think that's correct. I'll have to double check that. That's good with me. And then we'll just return the response. Okay, and now we can just run this. Now we haven't called this function. Just going to see if everything is happy. Didn't like my Gemini API key. Maybe I called it something different. Let me. Can you load terminal once you're using it? Yeah, I can. Yeah, what I'm going to do actually is very quickly just unshare my screen while I fix my API key issues. Okay. If you have this issue, let me know. What I'm gonna do is just maybe I probably just called the API key something different. I can't remember what I called it, so I'm just gonna redo that and then rerun this. Okay. It's a bit weird. Oh, I think I know what it is. You know what? This is a very weird error, and it's very annoying because normally this is fine. Like you have errors when you're developing. We debug them live on stream. I can't debug this live on stream because it's got my API key in it. Okay, I'm gonna pull my screen back up. We'll see if we can debug this live. So I've definitely got my key set as Gemini API key. But when I run this, we get the error, which means that it's not being found. And this is a bit interesting. Okay, you know what? We're gonna pivot. It's fine. We're going to pip install Python. Is it python.env or no? It's got a dash in .env. There we go. Okay, and now we're gonna make .env. Okay, and in here we're gonna say Gemini API key, and then we're gonna paste in our API key, which I'm going to do again off stream. Let me just remove my stream. There we go. Okay, perfect. And now I can pull this back up. Great. And now we're going to do things correctly. Well, I mean, we were doing it correctly before. I don't know why it wasn't working, but it's not worth the time it takes to work it out when this will work as an alternative. So let's do that. Yeah, we can load in our API key here. Now this should work. Load API key. Imports. And we will see if this works now. Right, perfect. Okay, so we're loading in our API key correctly now. Excellent. For anyone who missed that, that's python-env. Okay. Right. Let's get going. Just going to see if we have any questions. Yes. So I'm not actually 100% sure if this is going to work, but I think it should work. Gemini is set up to work with OpenAI's function calling. So yeah, I normally do use Python.env. I was just like, oh, this time it's just easier. Like, I don't have to make a whole env and whatnot. But like, this is better. This is the better way of doing it. Anyone watching, this is the correct way of doing it. I was just being lazy, and I shouldn't have been lazy. So there you go. But yeah, I hope you feel vindicated. But yeah, okay. Going back to your question, yes, we're going to try and use Gemini through OpenAI's SDK and see how that works. Cool. We'll see. I'm not like convinced, but like you try something new. This is not like a way that I've done it before. Okay. Perfect. Okay. Great. And so let's set messages equal to, we'll just do some tests. So we need a dictionary. Can I have that in a string, please? And yeah, we can have a system prompt. Yeah, fine. And then we can have a user prompt. That's whatever. Okay, I mean let's ask what's the capital of France and its population as of 2020, October 2020. As of 20, let's just ask 2025. It shouldn't be able to do this because it doesn't have 2025 in its training data, as far as I know. Okay, and then perfect. Okay, and then we should just be able to grab out our response, and we'll see if this is gonna work. Yeah. Okay. It's not gonna like this. Okay. It was worth a try. There is like a better way of doing this. We might have to use Vertex AI. Given we're low on time, I'm gonna suggest that we pivot slightly. Yeah, let's pivot a little bit. I was going to try and work this through in a notebook step by step, but I think let's let's try and run this in a full script, and let's try and let's I think pivot away from using OpenAI's client. We'll use Gemini's client. I think this is going to be substantially easier for us. Yeah. Okay. We're going to leave this here as like some nice little notes. And I'll just rename this to notes. And then let's. All right. Let's make simple agent.py. Okay. Right. Okay. And we will get started on a full agent script. Okay, so the reason that I'm pivoting to this is because I think it will be easier thinking at a higher level, building something overarching, and then debugging instead of trying to do bits step by step. Because getting a bit bitty can take a little bit longer. But like often, if you're building a project, it can be better for your intuition to kind of work section at a time. First out starting prompting an agent and then building a simple chain and so on. But we're going to just try and throw it all together at once. I think we've got an intuition for how this all works. So hopefully this is going to be nice and straightforward. Okay, and we're going to import pickle because we want to do some logging of bits and pieces, and we're going to load sentence transformers, which my linter never likes, but I promise you is installed. And then let's get our LangChain imports as well. From LangChain, Google GenAI, import chat Google generative OpenAI. So instead of using like the OpenAI client, I'm going to use it through LangChain, which is nice. Like this is a really great benefit of LangChain. You can see here that I'm importing all sorts of different bits and pieces, which is just going to make our life a lot easier because we don't have to construct all of these ourselves. Okay, so LangChain provides a lot of the infrastructure, which means that we don't have to do so much engineering work, which makes it nice. Okay, I'm going to use this for like, UI slash visualization. Well, it's not really visualization. Yeah, like a front end library. This is fine. Yay for LangChain. LangChain. Yay. There we go. Okay, this is great. And so the first thing that we need to do is set up our Gemini client, right? And we're not going to use OpenAI this time. We're actually going to use Gemini client. I wanted to try and make it like as model, like as agnostic as possible in the spirit of kind of keeping things open source. But like this is the way that I've done this before, and I think this is going to be quicker and easier. If you want to change it yourself, you can rewrite this class that we're about to write. And included in this, we're going to include a throttle and a retry to help deal with our potential rate limits. And we're not just going to do this. This is cheating. We could do this, but we're going to define our own class. Okay. And ooh, wow, that's a lot of stuff. This is going to be a wrapper, and it's going to be over the Gemini and LangChain model with throttle and exponential backoff. Exponential backoff is just when we try something increasing the time we sleep or pause exponentially. Okay, and we need to initialize this. So let's do that. And so I'm going to use some type hinting here. This is good Python practice, and we want Gemini 2.0 flash lights. We want our minimum interval to be a float, and we want it to be maybe half a second. And we want the maximum number of retries. We could set this to like a bunch of different things. I'm maybe going to set it to like 5. 5 is a good number. You could use 3 to be more conservative if you wished. Okay, and then we're going to pull in our API key. API key equals, and up here, let's do load API key with .env. This is just as before. All right. So we've grabbed ourselves an API key, and let's just say in the same way, if we don't have an API key, I think we want a runtime error, not a value error. That's technically more accurate here. Okay, and we can set our LLM up, and we can do that with chat, Google, generative AI, model equals a model, API key equals API key. Let's maybe look at the docs very quickly for this. LangChain, chat, Google, generative AI. So you can see here that we've got like a whole bunch of chat models that we can use. And if you want to use your own chat model, there's some guidance. This seems like an interesting thing to do. You can contribute. This is a great part of open source. I'm sure there are a bunch of other streamers telling you how to contribute to open source this week. But this is an option. We can set all sorts of different models here. Actually, oh yeah, so we can set some more kind of conventionally open source models, DeepSeek maybe. Although this is through the API provider, so your value may vary. It doesn't look like we can use OpenRouter as an option off the bat. If you have decided to use OpenRouter, let's see if we can find a good example. I don't think, yeah, I think you might have to run it through. Okay, this is what we want. There we go. So you can adapt the, well, you could probably use any, you don't have to use OpenAI's, but you could adapt the existing class to handle an OpenRouter key instead. And then I think things would largely be much the same. OpenRouter responds in very similar ways. And interestingly, they've demonstrated it with Claude here. I think actually you can just use Claude, yeah, for Anthropic. So there you go. And wow, look at all of this. So many different bits and pieces, but in particular, having structured output and tool calling is the most important aspect. And you can see like all of these basically have this from chat perplexity, which is like not going to be very helpful to you in this case, in my opinion. But we can see that with Google Gemini, we have basically a lot of the things that are useful. It's nice having JSON mode, but not required. Although, yeah, you could do so if you wanted to with another OpenAI key. Okay. Right. Ignore all of this. I might just like disable. Is this going to cause problems if I just turn them off? Excellent. No more errors. Goodbye errors. Okay. Yeah. You shouldn't have those errors that I'm having. But like, they're not actually errors. Nothing is going wrong. We've definitely got everything installed. But yeah. So what we're going to have in here is going to be a property that we're going to call. Yeah, we can call it last call time. I was just going to call it last, but like last call time is more accurate. And we're going to set this to a float, and it's just going to be 0. And then the minimum interval is just going to be our initial starting interval. We can like increase this over time. Perfect. Okay, so we've initialized the class. Now we want to create a throttle function. Okay, and this is going to allow us, when we call our model lots of times in this agentic loop of like reasoning and then acting, if we're doing it too many times, we'll slow down. Okay, so we can check how much time has elapsed, and then do that by getting the current time and then what the last elapsed time was as well. Let's correct that. This is what happens when you don't have pylons in. It's going to cause us problems. Actually, that's wrong as well. Don't disable pylons if you have it. It's just I hate the red lines, and I can't bother to work out what's going on with the imports. I know they are working though. Don't worry. It will run. It will run, I believe. Okay. My hope is that we can get kind of something working by the end of this hour, which I think is feasible, but it might involve going a little bit quickly. Last call time. Perfect. Okay, so I think this is good, right? So we're working out how much time has elapsed, and if the amount of time is less than the minimum interval, then we sleep for the time difference, right? So if the minimum interval is 5 seconds, and 3 seconds has elapsed, we will wait for 2 seconds, and then we will update our last call time and go for it. Okay, this is basically just a function that sleeps the thing. Okay, and then we're going to define invoke. Okay, and we're going to have self, we're going to have messages, and it's going to be a list, and it can have anything in it. Sure. All right. Okay. And let's just put a quick doc string in here. We're going to invoke the Gemini model with a retry on errors only. If we're not hitting the rate limit, we don't actually want to retry, because that's just a waste of time. This backup variable is going to say like how much time we should increase it by in the first instance. Oh, sorry, how much time we should sleep by in the first instance. So for attempt in range self.max retries, we're gonna excuse me, try and call the model, and we're gonna do that by first throttling if we need to. Remember, this is gonna check how much time has elapsed. At the moment, the minimal interval is 0, so it will just keep going through. It won't have to do any sleeping, and then it will okay. And this invoke, perhaps we should invoke with a retry. This invoke is different to our invoke. This is provided through LangChain and deals with us passing in all of these messages. We don't have to worry about any of the other bits and pieces. It just deals with all of them. Excellent. And then we can grab the exception and say, okay, if attempts is less than the number of retries minus 1, then we will sleep for the duration of the back off, and we will exponent it. We will increase it to the power of 2. Oh, sorry, times it by 2. Not to the power of 2. That would be pointless because the back off is 1, and that would do nothing because 1 times 1 is 1. Otherwise, we're going to raise the error. Okay. Perfect. Okay, so I think here, let's maybe make it clear what we're doing. We've got our client, and this is great, right? And let's just make a really minimal chain, okay? So the next thing that we're going to do is just make a minimal chain function, which is just going to be the response going into the, the prompts going into the response. Let's get that the right way around. It'd be pretty meaningless otherwise, okay? Perfect. And this is just going to be a function. As I say, we're going to call it minimal chain. And we will take in the client, which we've just defined as a class. We can put in prompt. We can put in, like, maybe we'll just call it questions, but a bit friendlier. The messages that we're going to be putting into our model are just going to be the system message, which is that yes, we're a helpful assistant, and also the human message. Okay, and then we're going to just invoke our client with retry. This is here, using our messages, and then return that. Okay. All right. Okay, maybe we'll like why are my capitals so weird today? Okay, so if name equals main, yes. So we'll initialize our client, we'll create a question, we'll grab out our answer using our minimal chain, and then we'll print what happened. Okay, I think this is good. So let's give it a go. And I'm just going to run this with simple agents.py. And we'll see whether we've made any mistakes so far. In the meantime, let's see if we've got any questions. Throw me all of your questions. Wow, loads of chat. Sorry, I've not been keeping an eye on things. Okay, well, we had some problems. Ah, I see. I can fix this quickly. This should be Gemini. If you copied me exactly, make sure you correct that, because that will not work. Okay, we'll rerun that. Right, let's have a look. Okay. What questions do we have? You can use the async OpenAI module. Ah, okay. This is maybe what I was hunting for. And you tried it and it works. Oh, amazing. You have to add the base URL. I see. Okay, yeah. This is maybe a good way of doing it. Some great shout outs here. This is why I love the hacker community. Together we have so much knowledge. It's good. Okay. Yeah. Okay, yeah. Python.env is platform agnostic. This is another reason that it's better. Yes. You're very correct. Piezo Freud. I want to say that. Is that how you pronounce your name? Yeah. I mean, I'm trying as best as I can to kind of talk through what I'm building, but yeah, this is helpful feedback. Thank you. Yeah, this is like a super simple kind of intro. Yes. If you wanted to make a more complicated model, you could check out the ones on LangChain, but like this is kind of like, if you've never built an agent before, you've never used LangChain before, this is going to be an introduction. This is also like an introduction into how to think about how agentic AI works and the considerations that we need to have, especially from like the guardrails perspective. We're going to be looking at that tomorrow. Yeah, boo to MS making Pylon some non-open source. Agreed. Okay. Cool. Yeah, I can try and explain more line by line going forwards. Hopefully so far it makes sense. I think most of it so far is fairly simple. Basically what we've built, talking through it line by line, I guess is maybe more granular than we need right now, but we're initializing all of these parameters when we initialize our client, which is just basically it's a glorified function where we try the API, and then if the API says nope, you've hit a rate limit, i.e. it throws an error, which we catch with this, then we give it some time, right? We increase the back off, we sleep for a little bit, and then we go again. Okay, this just makes sure that we're not spamming the API. Okay, and then this is just a function that literally just calls our invoke function through our class. Okay, and then this basically just runs the thing. Okay, so hopefully that makes sense. What's the difference between LangChain and Google's GenKit? I haven't used Google's GenKit. Let me find out. Okay, I mean, Google's GenKit looks like it does a similar thing. Looks like it's going to allow you to interact with tools and things. I mean, given it's a Firebase kit, I imagine it interacts with Firebase much more nicely. Yeah, you can use, using streamlined APIs for multimodal content. Structured outputs, tool calling. This is just another alternative. Like, I think there'll be different ways that they work, but they will fundamentally do the same thing. So I wouldn't say there's like drastic differences. LangChain is nice. I think both are open source, but LangChain is nice because it's pretty much standard and it's not locked into Google. So you can use it with other tools of your choosing. Yeah, sorry. No, not shuts off. When you sleep in Python, time.sleep, this just pauses the code. It pauses everything for however much time. Okay, it's like saying wait. Okay, if I said just stop, wait, that's the same thing. Yeah. GenKit isn't Google only. Okay, yeah. In that case, I think they're similar tools with similar functionalities. They're probably just competitors, right? I haven't heard of GenKit before, and LangChain, as far as I know, is like way more used. But your mileage may vary. Maybe the GenKit is better for you personally. Again, I'm not super familiar with it myself. So yeah. Okay, right. Let's get on with it. Okay, so we have a working model. We've got a super basic chain. We've built our first chain, and the chain is just construct the message using the system prompt, call the model, return the response. Okay, this is the simplest chain you can get. This is what we do, like at minimum, right? We just go from a prompt to a response. Okay, but like I think we maybe want to make something more complicated, and to do that we need some tools. Okay, and for now let's just create a super simple what should we do? Maybe just like a super simple search tool. Okay, and I'm going to give it this @tool decorator, and this is courtesy of LangChain. You can see here, and this basically allows us to feed it into our model correctly. Okay, and let's name this first search web, and maybe we'll put in a query, and that's going to be a string, and we're going to put out a string. Okay, and we're going to search the web for a query using, and we're going to use DuckDuckGo because let's make this a doc string. And we maybe want to be a bit more descriptive than this. This is going to be DuckDuckGo instant answer API, and we're going to return a summary. And this doc string is quite important because it tells our model how it works, right? And we probably, realistically, we want to give it the input parameters and the outputs as well. Let's see, any questions? Yeah, I've heard of Crew AI as well. I think this is another common popular one. LangChain is the one that I am I've heard of the most. So that's my take. Yeah, okay, right. So let's put in our arguments, and it's going to return these things. Yeah, this is great. Thanks, Copilot, for doing this for me. The reason that we give it, a more comprehensive docstring, even when we have quite a simple function in terms of input and output, is because we want our model to really understand what it's doing. If it doesn't understand, that's not going to be great. It won't really work. Okay, so let's first, this is going to help us with debugging. We're going to say searching the web for query. Okay, perfect. And Copilot really doesn't want to put in really wants to simulate the web search for some reason. We're not going to do that. And so the URL that we're going to use here is going to be https, and it's api.duckduckgo.com. Great. And then the parameters for the search are going to be query, yes. The format JSON is fine. No redirect one, no HTML. Don't think we need this. We do want to skip disambiguous. Yep. And then this is going to be the type. And we'll just call it like open agent. And this is going to be, this is good. Okay. Right, don't worry too much about that. This isn't a workshop on how to use the DuckDuckGo API. This is just hopefully going to work. And if it doesn't, we'll be sad, but it'll be fine because we'll fix it. Okay, and so we're going to use requests, and using our URL, and we're going to use a timeout, so we don't spam things out. Great. Okay. So we're going to get JSON out, right? And we can get maybe a summary, and so we use data.get abstract text. And this is like when you Google, you get like a little summary in each URL. We're just going to grab the first one, I believe, and then grab whatever it returns. So okay, this is fine. Actually, let's set that to just an empty string, and then we check if summary is empty. If it's empty, let's try and grab just some more data. This is the related topics. Nice. Okay. And then we can check. We want to check if it's a list. If it's a list, we want to just get the first item out. I don't think we want to do that though, because it might not be what we necessarily expect. So we want to check also if it's a dictionary, and if it is, then we want to get the text out. If it's not, we'll just set it to empty, and then we can set summary to yeah, let's limit it to the first 500 characters. This is a good idea so that we don't like absolutely use up all of our context on the search. And then maybe we will say like see, we'll maybe put this in a bracket, see more at and then we can get the URL. Perfect. Okay, and then all the way back here, we want to return the summary if the summary exists. Great. Or actually, we don't even need that. We can just do this. Copilot not very efficient. Okay, great. Okay, we have now got a tool. So this is good. We have a client, and we have a minimal chain, and we have a tool. And now we can build a slightly better chain. In fact, not a chain. Let's build an agent. Agent loop with tools. Okay. All right, and we'll pause for a breather. I'm gonna drink some water. Let's see if we've got this chat going on. You don't have to include an actual API as variable. Yeah, DuckDuckGo is really great. Do recommend, and it's free. Unlike Google, I think you have to pay for Google search. So yeah. All right. Okay. Looks like we're kind of pretty much happy. Everything is good. I'm going to keep going in that case. But do let me know if you have any questions. Okay, so now we're going to make our agent loop, okay? And we're going to make a class for this. And again, we're going to initialize, and we're going to use our client, of course, and we're going to need our tools, which is going to be a list of anything. And then we also want maybe max steps. And this is going to be, we can set this to like loads of things. I'm going to say 10. 5 is a little bit short. We're going to set the client. That's great. I think we're just going to pass this in as a list. I don't think we want to unwrap that yet, so we'll just have tools. We don't want to put messages in here. Oh, thanks for that. VS Code. Okay, we don't want to put. Can you stop, please? Thank you. It's because of this bar. So annoying. This line is too long anyway. Okay, and we will say LLM tools, and we're just going to use LangChain here. And LangChain allows us to do a really neat thing where we can bind the tools which we've created straight to the model. Okay, and remember that client.llm is just the initialized chat Google generative AI. So this is provided by LangChain, and as you can see already, LangChain is really doing the heavy lifting for us. Okay. Okay. It's telling us that we should have named it this, but we haven't. That's fine. Okay, so LangChain is really doing the heavy lifting for us in initializing our model, and also in dealing with the tools for us. So this is great. We've made a tool, really simple tool, and we want to set the bank steps as well. And all of that is more or less set up. So now we basically just want a run function. This is going to take in obviously self, all of the bits and pieces that we've just defined, and then it's going to take in a user message. This is like the question that they might be asking. Okay, you know, what is the capital city of France, and what is the population, for example? Okay, and we want to define messages. Maybe actually let's put a. Don't know why I did that. That's fine. Okay, let's yeah, that's fine. Thanks Copilot. I love Copilot for doing the documentation. I hate writing documentation. It's such a pain and a faff. Okay, so we're going to create a list, and in this list we're going to have all of the bits and pieces. But we maybe will make a better system prompt than this. Can you go away, please? We're going to say you are a helpful agent, okay, and you may call tools when needed. If you call a tool, output a JSON specifying tool name and arguments. Otherwise, output a final answer. Okay, great. Now we're instructing it to do this. This is going to make our life easier, but in theory, this is also handled by LangChain. It will require the model to produce the correct output, you know, when it acts. Okay, this is, remember, the React pipeline. When it acts, we need it to give us a JSON specifying the tool name and the arguments, so that we have a consistent format, so that we actually call the tool correctly. And we kind of think, oh, how are we going to make our model do this? Like, it will do all sorts of weird things. It might say, oh, sure, no problem, and then provide it. Like, how do we deal with this? Well, LangChain deals with this. This is great for us. You can also do this with a bunch of other different models. The hardest one, in my opinion, is Anthropic. You have to use a separate library called Instructor. But again, LangChain handles all of this behind the scenes. So whilst you can do this manually, it's not like impossible. It's actually not that hard. It is a faff, right? It's a bit of a pain. And the fact that, especially for all varieties of models, we can just do it centrally with LangChain is a big advantage for us. Okay. So, the other thing that I want to do before we get into things is I want to create a set, and I'm going to call it scene. And this is going to be to avoid repeated tool calls. If our model, like, you know, gets stuck in a loop trying to call the same search, maybe it's like, oh, what is the capital of France? What is the capital of France? What is the capital of France? It knows this already. We've seen it. We put it in a set, and then we will use this later to ensure that we don't repeat things unnecessarily. Just checking how much time we have. We've got about 5 minutes. I think we can, like, I think in 5 minutes we can bash out this little script. I'm going to go pretty quickly though. So we're going to go through all of our steps, and then in each step we're going to get our AI message. Okay, this is our response, and we can do that with our LLM with the tools, which we defined earlier when we initialized the class, and we can just give it the messages, okay, which we've defined just above. And if AI tool calls, right, then we have some tool calls to handle, okay? So let's just call this TC for shorthand, and we'll grab one tool call at a time. We'll grab the name and the arguments and the ID, and these are going to be like this. Perfect. Okay, so we're extracting those from the JSON. Okay, this is why we need it to be JSON. All right. Perfect. Okay. So we're grabbing out a key, and if it's in scene, we're gonna prevent us from looping infinitely, and we will add in our AI message to our messages lists, and we will add in yeah, we want to add in a tool message. Call ID equals TID output. I think we want content equals JSON dumps. And then we want output. And the reason that we're doing this, yeah, thanks. Let's go let me fix my problems for me. The reason we're doing this is because just it's going to make our lives easier dealing with JSON. Okay, and then we can add the key. This is obviously because we're continuing. This is going to be only in the case where the key wasn't previously seen. And then let's make a map of all of the tools, and so then we can check if our actually maybe we'll let it error here instead, and this will give more information to our model. We could deal with this with an if loop, but and actually we're not going to do that. We're going to do this, and then we're going to do dot invoke, okay, with the arguments. And again, this is LangChain doing all of the work behind the scene. Okay, perfect. Right, how much time do I have? Oh, I'm tight on time. Okay, let's see. Global Hack Week schedule. Who's on after me? What day are we on? Day 4? Ah, am I last for the day? We might overrun a little bit in that case. Sorry, hackers. I normally try and stick to schedule. Okay, we don't have anything for another 4 hours, so we'll overrun just a little today. We'll wrap this up, and then tomorrow we'll make this better. We'll make it concrete, and we'll make it a little bit more rigorous. Okay? Okay. So we're gonna now, in the case that we've managed to call our tool, we will add it into the messages, which is just basically all of the stuff that we're feeding into our model, okay? And we're gonna grab the output, which is gonna be the observation. So this is the observe stage, right? Like if we go back to our notes, did I have it here? Yeah, okay, so we have done the reasoning, we've got the action, and now we've got the observation. So notice we have, let's check this, reasoning, we're invoking the model, allowing it to call tools. We have the action, if it's called a tool, we allow it to act, and then we have the observation, we allow it to observe, okay? And then we're gonna continue, and then we can just return the AI content here. And the reason is, like at this point, we have had no tool calls, so we have a final answer. And we know this because we checked for tool calls here, okay? So we could have an else in here, but like we don't need it because we'll just continue through. Okay, great. And then one step back, we will return, maybe I couldn't complete the task within the allowed steps. Okay, so this is in the case that we take more than 10 steps, perhaps. Right, and maybe we'll have to change our prompting a bit. Maybe it will just like keep trying steps over and over again, but this should be okay for now. And I think we're pretty much there. Okay. Yeah. So let's run this again and ask a different question. Let's, instead of asking this, let's say, what is the population of the capital of France? Okay. And we'll run that. Please ignore all my notifications popping up and down. Someone clearly wants me. And we'll let that run. Okay. So let's have a little look. I'm going to pull this up here. So this is still using the original super simple minimal chain. And it's estimated it for us. Maybe we should say in 2025. And then we'll run that again. If anyone can think of a good question that the model won't know but needs to Google, that's good. So we want it to basically say, I don't know. And then we want to use our tool and show that the model does actually know when it's using the tool. Okay, so predicting the exact population of a city in the future is difficult. So this model was obviously trained prior to 2025, and so it's like, oh, it doesn't even know that we're currently in 2025. Okay, excellent. Okay, so this is fine, but we want to know for sure, so we want to give it the tool. Okay, and so now let's change this. In fact, yeah, we can print minimal change return response, and then we can okay, this should work. We don't need to import requests. I think we already have it imported. So we're going to run both now, and we'll see what it says. Do we have requests imported? Are we using requests? I don't think we're using requests. Oh, we are. It's fine. Okay, minimal chain response. We need to do some prettier formatting here. Okay, so it's got it in 2023. These are just estimates, blah, 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 blah. Okay. This is not ideal. I cannot fulfill this request. I do not have the ability to predict the future. So our agent has not called the tool. This is because it thinks it's 2023. That's not very helpful. So let's come up with a better question, because this is a prompting issue and not an implementation issue here, I think. What does a model not know? Let's have a little think. Any good questions that we wanted to try? Ask it a maths problem is one of the suggestions. This is not going to work because we haven't given it a calculator. Googling a maths problem is not going to give it much help. I'm trying to think of like something which is not in the training data but that is easily accessible by Google. Any suggestions? Any suggestions, anyone? I mean, like, we can ask it maybe what is the weather. This would be better if we had like a weather tool. Let's check what we put in here as well. Maybe we just ask, what is the population of Paris? Give the most up-to-date answer you can find, right? Because in theory, if it searches, this should be much better. Okay, so let's rerun this. Okay, so when we what has happened here? When we work on this tomorrow, we'll fix these bugs. Basically, I think we'll wrap up here. TLDR, something's going wrong. I don't know why we're looping so many times. I might actually just rerun that, because that was weird. We'll see if it happens again. Okay, this is looking a little bit more sensible. Okay, so this is saying as of 2023, this account. Okay, so our model encountered an error. Maybe we'll give it 3 more minutes till 10 past the hour, or 10 past the hour in the UK. I'm not sure what time it is for you right now. Hopefully not too late in the evening. Sorry that we're overrunning a little bit, but if you need to head out, you can. You can watch this back on YouTube at a later date. So what's going on here? Where are we potentially throwing an error? Let's before we let's print the message history. Okay, you can think of this message history a little bit like our very rudimentary scratchpad. Okay, hopefully this will include. I mean, this will include what the error is. What is going on here? I don't know what this is. Hopefully this will include a little bit of our. Well, it will include this, which includes the error, the tool name that we try to invoke. And it should also include what we've actually tried to do to call the. Yeah. Okay. Wow. This is unreadable. Let's shrink that and make this bigger. Okay. So we told it you're a helpful agent. Blah 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 blah. This is good. So I think our infrastructure here is working. I think we maybe are just having some problems with maybe our prompt setup. Okay. Human message. Yes. Great. So we called search web with arguments query population of Paris. Name request is not defined. Oh no. I'm a fool. I'm a fool. Okay. We get there in the end. You know, this is why we use Pylance, everyone. Don't turn off your Pylance. I even spoke, I was like, oh, I don't think we need requests. But we do, we use it here. So I don't know what I was thinking. Okay, right, this time I'm feeling much more confident. All right. Yeah, I don't want to be too explicit about asking it to use a certain tool, because the premise is that it has this reasoning step where it decides what tool to use. But obviously we're only giving it one tool at the moment, so once we give it more tools, we'll do that tomorrow. It will be a little bit more interesting and a bit better. Okay? Perfect. Right. Okay, let's see what we've got here. Okay. So the minimal chain response, like it's giving all this information. Yeah, this is from 2023. It hasn't said explicitly this time, but it is, and it thinks the population is 2.1 million-ish. So we've got all of this, blah 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 blah, and then where's our actual output? There we go. The population of Paris was 2,165,423 people as of January 1st, 2019. Now that's not great. This could be better, but it has correctly used the tool. Okay, so it's called the search. We've got the city of Paris has blah 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 blah. So this is very good, and we know this is exactly true, right? We know this is completely true because it searched it, or at least it could cite this for us if it wanted to, like if we wanted it to, right? We could make it return the URL, and then we could prompt it to cite the URL at every point, okay? Or we could even require it to if we wanted to. But even though this is less recent, it is more accurate, okay? And maybe doing something with dates is a bad idea, because when you Google things, sometimes it's hard to find up-to-date information on Google. But you can see here that we have built an agent that uses a tool correctly, and in the future, we're going to make this much more rigorous, we're going to make this safer. we're going to add guardrails. We're going to give it more tools. This is what we're going to be doing tomorrow. So come and check that stream out. It'll be starting around 24 hours from now, I think. So that's 1 p.m. UK time, or maybe actually, no, maybe it's 12. Should we check the schedule? Let's just check the schedule. Yeah. Okay, here we are. Okay, it's 12 p.m. UK time. And so that's 7 a.m. Eastern time, bright and early. Or if you're over in IST, I believe this would be somewhere around 4:30 p.m. So with that, I'll wrap up. Thank you for bearing with as we get through it's a slightly longer than normal stream. I hope you've learned a lot. I hope that going through some of those concepts was helpful to you. I look forward to seeing you here tomorrow. If you can't make it, don't worry. We will have it on YouTube as a recording. And of course, please give me any feedback. You can do so at mlh.link/GHW feedback. And I'll just pop the link for that in the chat. With that, thank you everyone for coming. Yeah, don't turn off your pylons. Yeah. I mean, you can't even turn it on. It doesn't work in VS Code and Cursor Void. Oh, yeah. I don't use Cursor personally, but yeah. This this is not great. I'm sure there's a similar linter though. There must be other things. Will we be sending the code today? Yeah, I can do that right now. I'm going to cheat instead of using the terminal and just initialize this. Normally, mistakes have been made. We don't have a git ignore. I'm glad I have not committed anything because we want our .env. We want our .env. Hopefully this will update. What I'm going to do for anyone who wants the code is I'm going to, seeing as we're over time, I will send it in the chat shortly, but I'm going to wrap up now. And so keep an eye on the chat. I'll send it through as a link in a minute. But thank you all for coming, and I will bid you all goodbye and hopefully see you tomorrow. If not, have a great rest of Global Hack Week, and I'll see you in the future. All right. Thanks you all, and